Hello, can you all hear me?
We can hear you fine.
All right, thank you. I'll
If
just
you're
share
not
this.
the speaker, now's a good time to mute.
Can you see my screen? Oops. Oh my God.
Not,
All right. Can you still hear me?
we can hear you fine. We can't see your screen yet.
Yeah, but I think Zoom is stop has stopped to work, so I had to shut down.
We see your screen now.
All right, okay, good. Oh, so just a pause. Okay, okay, let's start now. So, right. Okay, so this is about a continuation of what I have described previously, but I have come up with a new name for it. Uh, Simply crypto metaprogramming. Now I'll just skip to the quick definition, right? Just to make everyone stay focused. Now this is really Bitcoin simplified minus blockchain in 4 words, and I'll try to show you uh, how we can actually achieve the functionality of Bitcoin without the blockchains. Because basically, what Bitcoin is doing is using hash code to achieve what we call decentralized digital asset management. Okay. Now, just a quick review of Bitcoin. You can I have already shared this PDF, so you can click on this what do you call it, the link to access this page. Now this one is actually Bitcoin's page that shows you it is actually using this idea of hash of public key as the address. Now hash of public key is actually very fun is a fundamental concept in digital asset or decentralized digital asset, because we can use the hash of public key as a user ID, and therefore associate, okay, the hashes of all other digital assets. All right, now let me repeat. We will use the hash of public key as a user identifier, and any other kind of digital assets can be represented using hash code. And you will find that there is a very interesting property of hash code is that you can add up hashes together as a string. In the end, the composite string can be hashed together to produce another hash. All right, so I haven't found a name to describe this property, so I would just call it the hash preservation property, or anyone who has a sort of a better mathematical background would come up with a better name on that. And this page is quite interesting. It is actually showing how this operation work, the very fundamental operation for payment. And you can see that 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 whole this is the name of the operation, pay to pub key hash. It is actually a fourth line instruction. As you can see, the whole script is this one. All right. Sig pub key op dup op hash pub key hash op equal verify op check sig and so on. Now this diagram I'm sure is very familiar to all our fourth programmer. It's just showing you what happened to the stack, right? These two thingy, I mean, items are put on the stack, and these are the operations. So in the end, it will do this check signature and so on. Now, so I won't just I wouldn't go through the detail just to show you, to try to convince you that the whole idea of crypto meta programming started with Bitcoin and blockchain, but I am giving it a new name because I take away the blockchain, and so the next video is how we can see how it works. Okay, I hope YouTube is working. Okay, so you see that in this YouTube video, the user press the authenticate button, all right, and it comes out with a now. Now, this is the website that I designed myself to use the hash of public key as the sort of a login mechanism. Okay. Now, so it is different from conventional system like Gmail, right, where you use a phone number or the email address. Now, just now there was a quick action here. I'll just scroll back this thing here. Okay. You see that there is okay, this is actually a very important step where the Gen key button is pressed. I'll show you the code for Gen key in a bit. Now, what it does is that it actually generates what we call the public and private key pair. Now, this is done on the front end, meaning that the private key will not be shared uh with the backend. Now, this is what gives decentralized cryptography is the fundamental security. Okay. Now, just let's move on with this video. And okay, then the user click authenticate now. The user click authenticate again now. So what you see here is that this whole very long string here is actually the base 64 representation of the public key. All right. Now, so this whole thing is hash to produce the hash of public key. Now, obviously, you can have many different versions of hash of public key, depending on the algorithm, the length of the public key, and the length of the hash. But all these are similar, right? That is, you can change this algorithm and the format and the parameters quite easily. Now, which means that this gives a lot of flexibility in the choice of parameters for, getting the right kind of uh, algorithm and also the format that you wish to use. Okay. Now, so this part is to give you an idea of where this whole um, uh, what I was explaining just now is to give you an idea of how all this uh, how do we replace the function of Bitcoin using hash of public key and relevant algorithm. Okay, now this is the code where this is actually a combination of JavaScript and Forth. Right, this is I mean my version of Forth. I call it ForScript, PHOSCRIPT. All right, whatever the name that is irrelevant because we can change that. So what happened here is that if you click on the button Gen key, all right, it will actually call this function here. All right. Now this one is mapped to the JavaScript function. Okay, which I will show next. Okay, now I'll just show you the overall diagram, how it works. It's basically all right. The front end here, okay, sorry. The front end will generate the public key sent to the back end, where the back end will use the public key to generate a ciphertext uh with a secret phrase. Now, so the ciphertext is sent back to the front end. So the front end has to use the private key to regenerate the secret phrase and then send this back to the back end to verify, the front end actually is the owner of the private key uh, for whatever public key it claims to have. Now, this is the basic idea of most of the public key cryptography. But the point that we want to make here is that, of course, there are variations of this scheme, but this is the most basic. Now, obviously, if you want to produce something more advanced, obviously you could, all right? It's just a variation of this. Now, this diagram is taken from Mozilla website. All right, so it just shows you that, I mean, the sort of very rough steps that it takes, all right? So it will be using the public key as well as the private key, but of course I wouldn't give. I mean, there is no details given here, just to show you that how. I mean, these are actually a very similar mechanism. Now, the reason I want to show this is because this step is actually being used by the browser every time you make a AJAX call. Now, the problem with the conventional method is that the key pair, the public key and the private key, are not accessible. You can't really change it. I mean, as a programmer, you can't really change it. Now, obviously, I mean, I'm not being 100% accurate that you can't use it, but obviously you can. But it's just too troublesome, right? To use to change the way it behaves. So it might as well, we just start with a clean slate to mimic something similar, all right, so that we can achieve the functionality of blockchain. Uh, Kevin, can I check how much time do I have left? Kevin, are you there?
I would assume you've got more time. I had a question. I think I'm not following. You're saying that you don't need, like, I thought one of the properties with Bitcoin is that you need proof of work in order to be confident that you're not being deceived. Can you speak a little as to what you, it seems
All
like
right, okay. The proof of work part. Now, the proof of work part is actually a very complicated concept. You know. So what I'm trying to say is that the very fundamental of the whole idea of blockchain and Bitcoin is based on this idea, the decentralized user identifier. You need to have a user ID first, okay? Now, then whatever is called proof of work or proof of
stake?
whatever it is, uh, stake, yeah. Now, all the other ideas are actually built on this hash of public key, that is the user ID first, all right? Now, the problem with the blockchain community is that they bury this very fundamental idea of the hash of public key, in mountains of literature. So I actually discovered it by accident. I implemented this system first before I found the relationship with the blockchain. That's how I found out. Now, obviously, if once you start, it's just like what it could when you do no kneading, right? If you found the start of the thread, then you can unravel the whole thing. Now, if you want to work on that, yeah, that's how I would start. How to work backwards from this hash of public key and then the rest of this blockchain, right? Is Kevin there? I just want to check how much time I have left and to wrap up.
I'm
He's
here. You have 5 or 10 minutes more if you care to use it.
okay, 10 minutes. All right then. Thank you. Okay, so these are the JavaScript code that I write for to implement the public key and exchange diagram that I shown earlier. So yeah, what works is actually this part here. Now the way it is that we write in JavaScript is very strange. This is something that happened later. You would send this thing first, okay? This part. This is part that you send to the backend, okay? First you convert the public key to ASCII code. And yeah, this is where it gets interesting. So I'm actually using a fourth syntax, okay, on this command. So this one will invoke a fourth line operation at the backend for doing the encryption. All right, so I'll just show you how it works here. Okay, now this is the whole thing. Now the way I put it up here is to show you that this whole definition is saved in a JSON file. All right. Now, so you can see this is a series of for script code. All right, or you can call it for or whatever. All right, I'll just call it for script. That's the way I use it. Right. So you see B64D to decode it. Now this one generates the secret key. All right, it's a random key function. Okay, and then you change the hex. Now this is the RSA part, which is the one that is critical. All right, and because what happened is that yeah, you need to load the RSA object, okay, and then before you can run load key L key here. So you see RSA and L key. Now you get this pick whatever familiar operation in form and swap. Now RACR is this one to encrypt the secret message together with the public key. Now once you have that, then you send this thing back to the front end. So you challenge the front end to decode it. Okay. Now whatever I show up here is just to make it easier to read. Now this part is actually the sort of the engine, the loop, the big loop of how we process the for script code. Now this one is written in PHP. So there's an equivalent of PHP in the back end and the front end. So it has a similar structure. I'm sure all of you are very familiar with this. So I'll just show you the critical bit where the first part here, okay, is you see this explode. So it just break the space delimited string into tokens, okay? And then there's a big loop here, start of the big loop where you handle everything. And finally, you have a generic call user function, all right? So you match the predefined function. So as you can see, we have the predefined function shown up here. Okay. So that is how that part of what we call the hash of public key works. Now, this part is, the sort of the building blocks. Now, once we have the hash of public key, then you can start creating objects like this. This is called decentralized JSON. All right. Now, this is simply a JSON, except that inside the JSON we have the hash of public key and other hashes. All right. Now, this is what I call the association. If you associate the hash of public key with another hash, right? Then you create some sort of ownership, right? Now, this is a very important idea that I think I have not seen any literature explaining this. Okay, let me repeat again. If you associate, okay, in terms of string, you just put it side by side or concatenate, all right? Two hashes together, you create the idea of ownership. Now, obviously, this is what, Microsoft or Google wouldn't want to tell you. They just tell you that, okay, I manage your digital asset, so you don't need to bother about the mathematics of ownership. Now, I believe this is inside the blockchain fundamentally. Okay, you can find this code, all right, the equivalent code to do this, that you associate the hashes and then you hash the output. All right, so you can do this on and on. Like if you take this whole string, you hash it again, then it produces another hash. Then you add another hash. So it's like it's a very interesting mathematic method operation. I mean, I just want to say that I'm not a mathematician myself, but I hope to find the mathematics to express those mathematics, the abstract mathematics in fourth, right? Because I believe fourth can be used to break down very advanced and complex mathematics to do this. So this is I'm explaining this little idea here so that hopefully we can find collaborators and work on this because this is really important because what I'm trying to show you here is that adjacent string like this is the representation of any kind of digital asset. Okay, meaning whatever you have, your source code, your photo, your video, whatever you say, your comment and everything. Now, today, this is actually managed by the big company, Microsoft, Google, and everything. Like, for example, even they would take source code from free software and use it. All right. Now, which brings me back to the first slide, which I skipped earlier. That is why we are doing this. Now, if you look at this diagram, you may be very frustrated because that's how much money they make last year and the year previous. All right, 2023 and 24. Nearly 1.8 trillion, 10% growth, with the Apple being the guy which is losing Chinese market. If not, then they would be more than 10% growth. Now, remember, this company use unknown amount of source code by free software programmer. Now, why can't the free software programmer track the usage by this company, right? I mean, this idea of hash code is like, I would say, even older than forth, right? If you check the the IBM history, right? Somebody in IBM sort of invented or copied the idea of a hash code. Now, why is this idea of a hash code being used as an intellectual property not popular among the programmers? All right, okay. Yeah, I'll just check with Kevin again. Is my time up? Kevin, can anyone hear me?
Hang on.
Kevin,
I'm right here. Stay calm. Yeah. On regular meetings, we're not too excited about the time. So, yeah, if you want to wrap it up in the next let's say 5 minutes, that would be wonderful.
okay, I'll just wrap it up then. Okay.
Is is that within the realm of your
Yeah, yeah,
ability to?
I
All
have
right.
a lot of material to show. I'll just give you the next bit of the uh
So I see Andrew McEwen, the next speaker, has joined us, and like I say, next few minutes.
okay, I'll just show something quick here. Um, this is right.
Would you put the hash code in the executable so you can bill for it when someone runs it? Would the idea be on compile time to put it in the executable and then bill the client?
Yeah, there are many things that you can do with hash code. I mean, you see, fundamentally, hash code is just a lookup index. All right. Now, it's a very interesting lookup index because you do not need a centralized authority to create this lookup index, which is what gives the decentralized property, right? Meaning to say that if you store your source code somewhere and you create a hash code as a lookup, right? Then you don't really need a centralized authority like Microsoft or Google or any of the three-letter agency of US to manage it. I'm not sure I answer your question, but I think there are lots of
Oh, I was just thinking, when you compile the source code, you could embed the hash code in the executable, so you could bill someone maybe for the use or something like that. I don't know if that was the idea. How to bill. You said the organizations use the software without paying for it or whatever. I don't know if putting the key inside the source code when you compile it, because you can put names and versions and everything, but if you put the hash code, if you could then control the use or where it came from or who it belongs to or who's using it.
yeah, that's correct. Yeah, it can be done. Yes. Yeah. Okay. Anyway, I think we can take up the question, later because all I want to show you is that right. If I can. Okay, so this is actually a demo. Okay, you can access this page following the address shown in my slides. Now this is actually just a very simple demo which has two parts. The top part is to create the hash code. The bottom part is just a conventional uh sorry, let me just pause and go back. Right? It's just a form, all right? Now, what I try to show you is that the whole idea I call crypto metaprogramming is that now if you do this, then you can actually break the front end and back end, okay? And all you need to do is that you just send the uh, hash code, sorry, okay, this is what happened. The front end will send this thing. This is the hash this is the zip of the JSON result, right? Uh, and this itself is the JSON string. Okay, you have this name. Okay, and yeah, the hash of the user here. Okay, so you can see that now. Obviously, this is the PHP format. I mean, some of you may not be familiar with the PHP format, then it doesn't look like it. But the whole idea is that this whole string, that means it simplify your design, right? That means all the what we call the model view controller are just three separate components. It was made very complicated because whoever designed this whole thing, they don't want you to know that, you can actually break it. And if you break it, then, all apps becomes really simple. We don't need to make, nowadays, if you do this web app, you need to install like a few gigabytes of whatever libraries, but all it needs, if you actually use what I propose as a crypto meta programming, every app is just a few lines of forth, really. So that's the dream that we can achieve. So anyway, if you want to find out more details, you can look it up in this video. And so I'll finish my talk here. And any question, welcome. Thank you.
All right. Thank you very much. Any quick questions? So if you look in the chat, there was a PDF posted shortly before the start of the talk. If you're interested in this stuff and you want the links and the slides, I strongly encourage you to download the PDF for yourself. So the time for the exciting screenshot is upon us. Ne'er-do-wells such as Dave should turn on their cameras. Thank you, Dave. You're 2 steps ahead of me as usual. Those of you that couldn't make it to last month's annual CH Ting Memorial lunch, we missed you. I'd just like to say that I miss Ting and all of the things that he did to nourish us. And he made lunch. And I felt that that was too good to not hit again. I know you've heard it before. I tell the same 12 jokes over and over. You know, it's just a fact of life. Cut and paste and inattention to detail. That's the 2 hallmarks of my practice. Are we ready for the?
I'm ready.
Okay, light the fuse.
All right.
It doesn't. It's like one of these timers. You know, it may go off at any random time.
All right. I think I got it.
That's awesome. Jurgen, you're going to have to turn off your camera next month.